Good morning. Today we're covering Unit 1, Lesson 5, Intercepts and Graphing of Polynomial Expressions. So far in this unit we've looked at how to factor different polynomials, so getting them from standard to factored form. Now we're going to actually look at what do we do with them once they're in factored form. We have this idea of solving a polynomial, and when we're solving the polynomial, we're essentially just finding the zero. So x-intercepts of a polynomial function are called zeros, and let's just write here. We find the zeros to solve polynomials. So when you're asked to solve a polynomial, they're really just asking you to find those zeros. So since the x-intercepts happen when y equals 0, they can be found algebraically by setting y equals to 0. Or if we're talking in terms of functions, f of x equal to 0 and solving for x. The graph of a polynomial function changes sign, meaning it goes from positive to negative on the graph or negative to positive on the graph, only at x-intercepts that correspond to zeros of odd order. So correspond to zeros of odd order. So what I mean by that is if the highest exponent on an equation is x to the power of 1 or x to the power of 3 or x to the power of 5. Okay, all those exponents are odd values. So when the highest exponent is an odd value, then the graph changes from positive to negative, meaning it crosses the x-axis at those zeros. If x-intercepts correspond to zeros of even order, so if they correspond to zeros of even order, like x squared, x to the power of 4, x to the power of 6, 2, 4, 6, those are all evens, then the graph touches, I'm going to say, or kisses, but does not cross. So think about a parabola. If I just draw a sketch of a parabola here, and we draw a parabola that does something like that, right? At that 0, it touches the x-axis, but it doesn't cross it. So that's true of polynomial expressions, where if we think of x to the power of 3, so this could be an x squared graph or a parabola. If we think of x to the power of 3, x to the power of 3 usually looks something like this, and we can see that at the zeros, the graph is crossing from negative to positive or positive to negative. So this would be an x to the power of 3 or x cubed kind of function. So we're going to look at some examples of this. So once we identify the zeros, we can plot those zeros, but then we might need to test points on either side and between the zeros to just do a rough sketch of a polynomial function. So we're going to say first, find zeros and plot, and then 2, find additional points to sketch. So let's look at this first equation. We have a cubic or an odd function that we're going to start with. Remember, a cubic, it just means the highest degree is x to the power of 3, and we would say 3 is an odd function, right? So solve and graph the following. So in order to solve, we want to find the zeros, right? Whenever we see solve, it's asking us to find those zeros. So in order to find the zeros, we need to first get it into factored form. So we look at f of x equals 2x cubed plus x squared minus 15x. And we have to think about how we're going to graph that. how we're going to factor that. So I recognize that there's a common factor of x in this equation. So I'm going to common factor out x. When I do, I'll have 2x squared plus x minus 15 left. Okay, so from here to here, we common factored. And then from there, looks like I have a complex trinomial. I have 3 terms, so I'm going to use SPF. So when I set up my SPF, I'm going to need 2 numbers that add to that middle number, which is a positive 1, and multiply to my a and my c value. So 2 times negative 15 is a negative 30. So what 2 numbers will do that? If I think about my factors of 30, I think 6 and 5 will do that. Let me just write that a little bit more room. So we'll say 6 and 5. And then we have to decide the sign on them. So 6 times 5, yep, that's 30, but it needs to be a negative 30. So 1 needs to be positive and 1 needs to be negative. It needs to add to a positive 1. So that means my 6 should be positive and my 5 should be negative. So positive 6 plus a negative 5 is going to be a positive 1, and 6 times negative 5 is a negative 30. So we're going to decompose that middle number of 1x, or split it in half. I'm going to put a plus 6x and a minus 5x, and then minus 15. Okay, so we just decomposed or broke apart that 1x into 6x minus 5x. So now we can factor by grouping. So I'm going to group these 2 together and group these 2 together. And then common factor out of those. So we have x here. And then out of my 2 terms I grouped here together in red, I'm going to common factor out a 2x. And then I'm going to have left over x plus 3. Out of the 2 terms I put here in green, I'm going to common factor out a negative 5. When I common factor out a negative 5, again, I'll be left with x plus 3. So now I can common factor out the common bracket, right? I have an x plus 3 on this and an x plus 3 here that I can common factor out. So common factor out that x plus 3, and then we're just left with 2x minus 5. So great, now we're in factored form. We can identify our zeros. So recall in past math classes, if we want to identify our zeros, we're going to set, we'll say to find zeros, set each factor equal to 0 and solve for x. Okay, so I'm going to take this factor here, I'm going to set that equal to 0, so x equals 0. Nothing to isolate there, x already equals 0. And then we'll take the next factor, this x plus 3, we'll set that equal to 0. And then we have to solve for x, so I'm going to subtract 3 over to the other side, so x equals negative 3. Finally, I have 2x minus 5. I'm going to set that equal to 0 and then solve for x. So I'll add the 5 over to the other side, so we have 2x equals 5, and then divide both sides by 2. So x equals 5/2, or 2.5. So zeros are 0, negative 3, and 2.5. So let's graph those on my axis here. So I'm going to do 1, 0 at 0, 1 at negative 3, and 1 at 2.5, right about there. Okay. I know I have a cubic function here, but I don't know kind of what's happening between these points. I do know, because it says here that any zeros of odd order, well, all of my zeros here, they have no exponent on them, so we can assume these are all to a power of 1. So that being said, if it's an odd order, it says that the polynomial is going to change sign. So it's either going to go from negative to positive or positive to negative, something like that. We don't know which direction, but we'll do this for now and kind of see what happens with the graph. Maybe we'll have to change which way we're going with those. But if it's a zero of odd order, which it is, they're all to the power of 1, then we're either going to go from positive to negative or negative to positive. So let's test some points. All right. So let's set up a table of values on either side of and between the zeros. All right, so we'll have x, because this is f of x. You could do y too, but we'll do f of x on this side. So we had a 0 at -3. So I'm just going to do one number on the other side of that. We'll do -4. We had a 0 at -3, and that our y value was 0. And then we had another 0 at 0. So I'm going to pick some point between -3 and 0. We'll just say -1. Doesn't matter which point. We don't need to know every point, just kind of what's happening between our zeros. And then my next 0, so at 0, my y value is 0. And then my next 0 was 2.5. That's a 0, right? So I'm going to pick a point between 0 and 2.5. We'll just pick 1 again on that side. And then we'll have to pick a 0 or x value on the other side of 2.5. So we'll just pick 3. So now let's sub in f to the -4 and see what we get when we substitute it into the equation. And we'll sub it into the factored form because that's easier to sub into. So f of -4 is going to equal -4, and then in brackets, -4 plus 3, and then in the other brackets, 2 times -4 minus 5. So if we simplify this, we'll have -4, and then -4 plus 3 is -1, and then 2 times -4 is a -8. -8 minus 5 is a -13. So f of -4, a negative times a negative times a negative is going to be a negative, and that should be a -52. So we'll put a -52 in there. So go ahead and pause the video and then fill in the rest of the values for the x's in the table of values that we have here. So what's the f of x, or what's our y value? We plug in a -1 or a 1 or a 3. Okay, so there you go. I plugged in the rest of our values here for our table of values. So we can take a look at and see what's happening on our graph between the zeros and on either side of them. So at -4, 1, 2, 3, 4, our y value is a -52, so that's going to be somewhere way down here, right? Way off our graph. We're down here, okay? This is just a sketch, so it doesn't have to be completely every point dead on. The next graph point we have is -3, 0, which we already plotted was one of my zeros. And then the next point is a -1 and 14. So 10 would be right at the top, so 14 would be somewhere up here. So you can see that from that 0 of -3, the graph does cross from negative to positive, and then it goes all the way up here. And then when it comes to 0, we go back down. Okay. And we're going to cross again. So at 1, our y value is a -12, so somewhere down there. Like that. And then 2.5 is back up to 0. And then finally at 3, the graph goes up to 18. So we'll say somewhere up there. So you can see each time we crossed the x-axis, right? We were going from positive to negative or negative to positive. So on our first 0, we were going from negative to positive. And then on this 0, we went from positive values in y to negative values in y. And then finally at 2.5, again, we were going from negative values to positive values. So let's just make a note about that. all zeros were points where the graph crosses the x-axis. And we'll just put in brackets odd order. Right? They were all zeros of odd order. Okay, let's take a look at another example. So this says solve and graph the following. So again, we are going to first factor this. So I look and see again, I have a common x I can take out here. So I'm going to common factor out an x. And when I do, I'm going to be left with x cubed minus x squared minus 3x plus 3. Then from there, I'm going to try to factor by grouping because I look at this and see that my first two terms look like they have something in common that we can factor out, and my last two terms look like they have something in common that we can factor out. So from that first two terms, I'm going to factor out an x squared. There's an x squared I could factor out of both those. When I do, I'm going to have x minus 1 left. And from that second group, I'm going to factor out a negative 3. When I do, I should have x minus 1 left again. So you can see I've created that common bracket that I can pull out front. Okay, so we have x, and then I'm going to pull out that x minus 1, that common bracket. And finally, I'm going to pull out that, or what I'm going to have left over is the x squared minus 3. So now remember, we're going to set each of these equal to 0 to find our zeros. Oops. Equal to 0. Okay, so my first 0 is going to be x equals 0. And then this x minus 1 equals 0, I can move the 1 over by just adding it. And this last one, x squared minus 3 equals 0, I'm going to add the 3 to the other side. And now we still have this square root we need to get rid of. So remember, when we have a square root, or when we have a term being squared, we square root to clear the power of 2. All right, so I'm just going to write another step of that. So we're going to do square root of that, and we're going to do the square root of 3. So that's going to leave us with x is equal to plus or minus. If you took the square root of 3, you're going to get 1.7-ish. Okay, remember, if you take the square root of something, the answer can be the negative or the positive version of that, because if we square the negative or positive version, that'll get us back to that square root of 3. Okay, so let's plot those zeros. So zeros are 0, 1, and plus or minus 1.7. Okay, so negative 1.7 would be our first one, so that'll be somewhere right about there. Then we have a 0 at 0, a 0 at 1, and a 0 at 1.7. So they're all kind of tied in there really closely. And then finally, we're going to do some test points. I'll do some test points over here. I'll just write test points. Remember, those are going to be on either side and between our zeros. So my first 0 was a negative 1.7. And we know it's going to be 0 there. Let's do a test point, though, on the other side of that. And then we'll do our 0. So let's do a test point at negative 2. And then negative 1.7 was my first 0. And it's going to be 0 there. And then our next 0 was at 0. And then our last 0 was at 1.7. Right? Oh, no, 1. We have a 0 at 1 and a 0 at 1.7. I knew we had 4. So we have a 0 at 1 and we have a 0 at 1.7. So I'm leaving some space so that we can do some values between all of those. So between the negative 1.7 and 0, we'll just do negative 1. That seems like a simple choice. And now we have to see what's going on between 0 and 1. So I'm just going to do 0.5 or 1/2 to see what's happening between those two zeros. And then same, between 1 and 1.7, I'm going to do 1.5. Okay, so if I substitute in a -2 into our factored form, when we think about that, we'll do f of -2 is equal to -2, and then in brackets we'll have -2 minus 1, and a -2 squared minus 3. Remember, if we're squaring something, we should write it in brackets so that that squared term applies to the whole thing, the negative as well. So we'll have f of -2 equals -2, and then -2 times, or -2 minus 1 is a -3. And over here we have a -2 squared, which is a +4, and then 4 minus 3 is 1. So we have -2 times -3 is a +6, times 1 is just going to be 6. Okay, you should pause the video at this moment and finish filling in the rest of the table of values. Okay, so there you go. There's your rest of your values if you were to plug them in to the formula. We should do one more on the other side of our last zero after 1.7. So if you plug 2 in to that factored form, you should get 2 for your y value. So let's plot those points and see what the graph looks like. So our first point in our table of values here is -2 and +6. So -2, 1, 2, 3, 4, 5, 6, right about there. And then we have our 0, -1.70. So we start at this point, we're moving down to our 0. And we can extend past that, draw an arrow. And then at -1, our y value is at -4. So right about there. So we come down to -4. And then at 0, we come back up to 0, right? And then we did another point between 0 and +1, because those are both zeros. So if we look at 0.5 for my x value, my y value is 0.7. So it's not going very far up before it then comes back down to 0. And then same for at 1.5, my y value is a -0.6. So again, not very low before it goes back up to that 0. And then at +2, our y value is 2. So it still crosses at those zeros, but not very far before it comes back up to the x-axis. So there's a rough sketch of what that graph would look like. And again, they're all zeros of odd order, right? We had 1, 2, 3, 4 zeros. Let's just highlight our zeros. So we had a 0 here, 0 at 0, 0 at 1, and 0 at +1.7. So these are all zeros. Oops, we didn't want a highlighter again. If we go back and look at the equation, these were all zeros of odd order. So they cross the x-axis, right? If we look on our graph, our zeros are going from positive to negative here, and then they go from negative to positive on the y values, and then positive to negative, and then negative to positive again. So they're crossing the x-axis each time at a 0. Okay, let's look at one more example in terms of solving or finding the solution for a polynomial, in particular quadratic. So another way to find a solution or an x-intercept is to use the quadratic formula. Sometimes we might not be able to factor, and we've learned in previous math classes that if you can't factor, you should use the quadratic formula. So maybe used to solve quadratic equations in the form f of x equals ax squared plus bx plus c when factoring is not possible. So we'll just highlight that too. So when factoring is not possible. We should leave the answers in exact form, okay, by simplifying the radicals. If you're asked to leave it in exact form, then you have to leave those radicals there, because as soon as you express those radicals in a decimal, you're rounding in some way. So if we look at the example, solve f of x equals negative x squared plus 2x plus 11. So remember that our quadratic in standard form, I'm just going to write over top so you can see where the a, b, and c come from, is ax squared plus bx plus c. So our a is our coefficient that's on our x squared, our b is our coefficient on our x, and our c is our constant that's being added at the end when a quadratic is written in standard form. So once we identify a, b, and c, we can then sub into our quadratic formula. So let's see. In this case, a is equal to, well, my coefficient on x squared is just a -1. Our b value is 2, and our c value is 11. So once you have those, you're going to sub them in to this quadratic formula. Okay, so let's set it up. So x equals, and then we have a negative b. So a negative b, in this case, is 2. And it's always a good idea to put your substituted values in brackets so that you're sure that you're capturing the negative or the positive sign on them and we don't mess up a sign somewhere along the way. So negative b plus or minus the square root of b squared, which is 2 squared, minus 4 times our a value of -1 times our c value of 11. All of that is going to be divided by 2a, or 2 times -1. So from here, we always want to simplify the top first. Okay, before we deal with any kind of thing going on in the denominator, we're going to simplify the numerator. We have x equals, so a negative, and then in brackets 2, we can write as -2, plus or minus, and then let's simplify what's under our radical here. So 2 squared is 4, and then we have a -4 times a -1, which is a +4, and then a +4 times 11 is a +44. And then our denominator, 2 times -1, is just -2. And we'll keep simplifying that numerator. So now we'll have a +48 divided by -2. So when it says leaving those radicals in exact form, we should look at, see, can we simplify this radical 48? Meaning, can we write it in a form that has a perfect square in it? So what we're going to do is we're going to split this radical, so right, split into factors where 1 is a perfect square. And remember, we went through that list of perfect squares before. So we have to, where 1 is a perfect square. So thinking about radical 48, we have to think what factors of 48 could be perfect squares. Okay, so I'm just going to write my factors of 48 over here. Okay, if I were to list them, we have 1 in 48, 2 in 24, 3 in 16, 4 in 12, and 6 in 8. And I think that's all of them. So if we look for some perfect squares, well, we have a perfect square here. 4 is a perfect square, and 16 is a perfect square. But we want to simplify it as much as possible. So we're going to pick the biggest perfect square. So we're going to pick this one right here, this radical 16. So I'm going to rewrite that radical 48, break it up into those two factors. So one's going to be a radical 16, and we're going to multiply that by a radical 3, because 16 times radical 3, radical 16 times radical 3 is a radical 48. So we're going to write it like that. Now we can go over here to just finish this off. So now we could simplify some of that radical, right? We could say the square root of 16, x equals -2 plus or minus. The square root of 16 is just 4, so I can write it as a 4 divided by 3 is going to be a -2. Okay. Now I look and I see that I have these even factors when then here. I have a negative 2, 2, 2. Those are all even numbers. So I should be able to factor out a negative 2 from that. So I'm going to factor a negative 2 out of my numerator. So then you're going to be left with 1 plus or minus 2 radical 3, right? If I take a negative 2 divided by negative 2, that just simplifies to 2. 4 divided by negative 2 just simplifies to 2 as well. So now these 2's cancel out, these negative 2's, and we're left with 1 plus or minus 2 radical 3. So that's it if we wanted to leave it an exact value, right? 1 plus or minus 2 radical 3 is the exact value or solution to that. If we wanted to write it as a decimal, we could just calculate that. We could do 1 plus 2 times radical 3, or we could do 1 minus 2 times radical 3. And if we did, we would get a negative 2.46. And if we were to add them, we would get x equals a positive 4.46. Okay? And this is your solutions or your zeros. So if you can't factor, quadratic formula is always what we should then use to find the solutions or find the zeros.